So when we look at the first question, they give you the AI that I asked to create some of these questions for me. I didn't catch this mistake, so I want to make sure I discuss it, and I discussed it with some of the groups up here. They asked you, what page was that on? I think for the AP. This is the AP problem, I believe. Yeah, and they say in the AP section, they go and they say, what happens, but they only give you half the problem. And it's, in order to answer the problem, you have to ask this. You have to actually ask this question: what happens if you cross a big T, little t plant with a big P, little p, and big R, little r? So it's a trihybrid cross. Trihybrid, and I'm assuming that that's what they meant. That's why they didn't. The AI, I say they. The AI did not put it in there because they assumed you knew that trihybrid meant you're crossing two of these. But it's not what it wrote, and I should have caught that, and I apologize. And I'll post this as well. So this is what they mean, this kind of cross. And like I told you in class, doing a Punnett square with three sets of like gametes that are mixing up all three of these, all the different gametes you can make with, it's just, instead of 16, you'll have 64 squares. And it's just going to get unwieldy. And then you have quad, you can worry about 4 genes. And you know, there are diseases in the human body that deal with 8 genes, even skin colors, 8 genes. And that's 2 alleles minimum each, not even counting the albinism gene, which is the master gene. So that's yet one more inheritance pattern, one more gene. So when we're talking about these kinds of calculations, a Punnett square becomes just irritating, if not a waste of time. So what you do is you ask yourself, again, the question I tell you is the most important question: what can each parent give? That's it. That's the question you have to ask. Now, when you're doing this, then you have to ask yourself, and the question that they're asking, the question that the AI is asking, is what are the chances of getting T blank, P blank, little r? Well, in these first two, it's asking you not to ignore the second one. It doesn't care what you get over here. What are the odds of getting a T or a big P? It's 50%, right? What the other parent gives doesn't matter, and for these two. So the odds of, what it's asking you is, what are the odds of getting a big T from one parent? Let's pick this one as the parent. It doesn't matter since they're both the same genotype. The odds are 50% to get a big T. But it wants to know what are the odds of getting big T and a big P and 2 little r's, ignoring the first two, these two. Well, that would be 0.5 times 0.5, right? Because I'm ignoring the other parent. But what are the odds of getting 2 little r's? Well, that's the odds of getting a little r from the first parent and another little r would be multiplied. So it's 0.5 times 0.5. Now multiply all those together, and you're going to get the odds of getting this genotype. And so when you're talking about and, then you're multiplying. If you're using or, then you're going to use a sum, addition. All right. So we tried in our discussion, our small group discussion over here, to try to add, we're like, some of the kids were like, isn't it T or something else? To get a T from this parent or that parent. Don't do that, because this is odds of getting a big T. You just don't know what the other parent's going to give. It doesn't matter to the problem. They could have asked you what are the odds of getting, they could have asked what's the odds of getting big T, big P, and little r. Well, then that would be the answer there would be 0.5 times 0.5. Those are odds of getting big T, times chance of getting a big P is 0.5, times chance of getting a little p is 0.5, times little r, which is 0.5, times 0.5. So you can multiply all those together and get the odds of getting this particular genotype from that cross. Does that make sense? And with a calculator, with a simple calculator, you can easily, you don't even need a scientific calculator, easily come up with odds. And when they say odds, when I say odds, I should clarify that. I say odds, I mean ratios or fractions or percentages. You see, all of these, they're different. They do mean different things, but they all are interchangeable. So 1 to 2 is the same as 1/2, which is the same as 50%, right? They all mean the same, but they're all formatted differently. This is out of 100. This is 1 out of 2. This is 1 to 2. So they mean slightly different things, but they're all interchangeable. So when you're looking at that Punnett square and you say 1 out of, and that brings me to the first simple Punnett square where you had little b, I think it was crossed with big B, little b, right? No, it was more complicated than that, wasn't it? What was the first one? What were the two letters? In the first Punnett square, that was a dihybrid cross. That was a dihybrid. This was a trihybrid. The dihybrid cross they given you is what?
Big B, little b, big R.
So they had this, and they crossed it with this,
Little b. Yeah.
right? And they crossed it with this. So again, you ask that first question, what can each parent give? This parent can give up to 4 different ones and give big B, big R, and someone said, well, how did you get that? You just use FOIL. This one, then that one, then this one, then that one, right? So those are the 4 different gametes you can get. Big B, big R, big B, little r, little b, big R, and little b, little r. Those are 4 different eggs or sperm, depending on which is that what you're dealing with here. But this creature here can only produce 1 different sperm or egg, 1 different gamete. This one can only produce big B, little r. Yes, it'll produce 4 of them, but they're all going to be big B, little r, or little b, little r. So there really is no use to go any further than that and just make a single column and make it out of 4 instead of out of 16. But understand, even if you would have made the entire chart and did the 16, so you could have done that. It would be the same thing. So it doesn't help, because what it turns out to be is 1/4 this kind, 1/4, 1 out of 4 here, 1 out of 4 here, and 1 out of 4 here. It would be the same for these columns here, here, and here. So really, but it would be out of 16. So it'd be 4 out of 16. So think about it. 1 out of 4 is equal to 4 out of 16, correct? Aren't they the same? So I think in math they do that, right? And then 1 out of 4 equals 4 out of 16, just because one's reduced, that's all. So what you end up doing is wasting your time doing the rest of these Punnett squares. Actually, Punnett squares in general are really a waste of your time, because all you really have to ask yourself is what are the odds of this happening, and then multiply or add depending on what your situation is. Why was it 0.5? Is that what you're asking?
No, I said 0.5.
Yeah, in this case, if it was, you would say, well, the odds, what, if you were to ask me, oh, why is this not working? Okay. So if you were going to ask me a question out of this one here, and you had, what are the odds of getting, oh, the pencil must be dead. Okay, I'm going to have to write with my finger, it's going to get messy. So if you go, if you're going to say, what are the odds of getting big B, big R, little r, we know it's 1/4. That's it. It's 0.25 for every genotype. With the odds of getting big B, little r, little r, little b, big R, little r, and little b, little r are all 25%, or 0.25, or 1/4, or whatever you want to say. But now if I asked you, what are the odds of getting what are the phenotypes here? What are the traits? What's little b get me? White. And what's little r? Rough, I think. Wrinkled. Smooth? Okay. And the big R is wrinkled. All right. So little r is smooth. And so smooth and white, what are the odds of getting a smooth white child? And then what's the B, big B?
Black.
And then a second child is black and wrinkled. Right? I say child, I meant offspring or whatever.
It's rough.
Is it rough and smooth? It's my bad. Well, I just don't want to confuse anybody. Somebody going home or watching at home that doesn't know what we're talking about. So rough, is it?
Yep.
All right, so rough, smooth and white, or black and rough. And rough, not or, and, right? So the chances of getting smooth and white is 25%. That's easy. And the chances of getting black and rough is 25%. So it's and. So those two multiplied times each other gives you the chances of getting 2 kids in that order, right? So consider that when you're doing these problems. This kind of math really saves you a lot of time on a test. It's very, very time oriented. It's very stressful. Because as you can tell, there's a lot of questions, a lot of reading, and then you have to answer quickly, and they love to confuse you. All right, I hope that helped.